I would suggest that you pause the video and try the warm-up problem. All right, so hopefully you tried this. Let's go ahead and let's talk through this. So to list all congruent statements about the diagram below, we're looking for markings that are the same. So we're looking for congruent segments or congruent angles. So hopefully we notice that we've got several segments with the same tick marks. So I noticed that the segment DC has 2 tick marks, and so does DE. So I have to use the segment bars because segments would be congruent then, and so those two are congruent. I also see 2 segments with 1 tick mark, okay? Even though there are arrows in this picture, you can't have congruent rays and you can't have congruent lines because those extend infinitely. You can't pinpoint or measure that, so you can only measure segments. So notice that BL, that segment has 1 tick mark in between them, and so does KF. So those are 2 segments that are congruent in this picture. And then hopefully you notice that I see several angles that have the same markings. Notice that they both have a vertex of A. Because there's more than 1 angle A, we have to use 3 letters. So if I follow the letters, I'm going to say C, A, and then if I go here, I can either say L or B because both of those points are on the ray, so I'm just going to say B. So angle CAB makes that marking congruent to then, if I look on the other side, we got angle, I'm going to say EA, and then once again, there's K and F on the same ray. You can pick either one of those. I'm just going to say F. But I had to have A in the middle because it was the vertex. I had to use 3 letters because there's multiple angle A's. It looks like those are the only 3 sets of markings in this picture. So those are all the true statements. All right, so today we're going to get into lesson 1.5. You looked at a vocabulary video yesterday, so these words should hopefully make sense. Today we're going to identify midpoints of segments and identify bisectors and trisectors of segments and angles. All right, so my first question is, do rays or lines have midpoints? And we need to explain. Well, I kind of just talked about it a little bit in that warm-up. Okay, when we are talking about lines, they extend infinitely in either direction. When I talk about rays, they extend infinitely in one direction. If something keeps going and going and going, we don't have a true, this is where the middle is. So do rays and lines have midpoints? Our answer would be no. So once again, that would be because neither have a specific length. Okay, you can't measure something that continues to go. Okay, and that's because they extend infinitely in one or both directions. Therefore, a middle cannot be found. And that's the whole point of a midpoint. It's locating the middle of a segment. So no, rays and lines cannot have midpoints. All right, so it says, if the segment AB bisects the segment DE at point C, what conclusions can be drawn? So the fact that we're talking about bisect, hopefully we're okay with knowing, okay, bisect means we're going to be dividing into 2 congruent pieces. Notice that what's being bisected comes after that vocabulary word. So it's the segment DE that is being bisected. So if we look at our picture, we can mark that up. If it's being bisected at point C, that means that the segment DC and the segment CE are going to be congruent. So segment DC is congruent to segment CE. That's something that we can conclude about this picture based off of the given information, okay? Even though it might look like that segment AB is also being bisected, we cannot assume that. And so because I'm not telling you that segment DE bisects segment AB, it's only the segment that comes after the vocab word, which we know for a fact is being then, in this case, split into two. So that's the only thing that we can conclude about this information. If we look at this next one, it says if the segment AB is congruent to segment BC. So these two segments, I'm going to mark them the same. They're congruent. It says what conclusions can be drawn. So the fact that we have segment AC being broken into two smaller pieces, they happen to be broken up at point B. So hopefully it's okay that we say point B is a midpoint of the segment AC. Okay, AC is being bisected, it's being broken into two. So basically, I kind of also talked about the word bisect. That's something else that we can conclude. There's a lot of things that bisect a segment. A point can bisect a segment, a ray can bisect a segment, a line can bisect a segment, another segment can. Based off of this picture, though, I'm just going to use what the picture has. Notice that RS has arrows going in either direction. So we technically have a line here. So I'm going to say that the line RS bisects, and then once again, it's bisecting that segment of AC because I know that AB and BC are congruent. So those are two things that are conclusions based off the given information. In this one, we're saying to use all four terms to describe the picture below. So looking at this diagram, we have to somehow come up with the phrase with non-collinear. We have to say angle bisector, ray, as well as congruent. Okay, you can try to put that all into one sentence if you want, or you can have multiple sentences, but we just have to make sure that we use all four of those terms correctly. So let's start with the first term of non-collinear. Remember, non-collinear deals with points. They need to be points that are not on the same line. So looking at points that are not on the same line, I'm going to say that the points A, B, and D are non-collinear. Because notice that they are forming an angle. You cannot connect one nice straight line through all three of those points. So that takes care of that one. Now we have angle bisector, ray, and congruent. So once again, you can use them all in one sentence. You can do 4 separate sentences or whatever. So I think I'm going to start combining words. So notice that in this picture, we have 2 small angles that are congruent. Notice that the 2 angles that are congruent share the same ray of BC. So I'm going to say that the ray BC, and because I've got 2 smaller angles congruent within a big one, ray BC, let's see, is the angle bisector. So that takes care of ray, that takes care of angle bisector. So ray BC is the angle bisector of the angle ABD, creating 2 congruent angles. And notice that congruent was another word that I wanted to use. So I actually was able to use 3 different terms in one sentence there. But the ray BC is the angle bisector of angle ABD, creating 2 congruent angles. And that's just based off of our picture. All right, if we take a look at this next one, we're told that the ray BD bisects angle ABC. So once again, we can mark up our picture. Bisect means to divide into 2 equal pieces. So I marked each of those smaller angles as congruent. We're also told that this big angle of ABC, we're told that this is a 75-degree angle. Two things we want to find. We want to find the measure of the angle ABD as well as the angle DBC. But notice that those two are technically the exact same angle. They're both congruent to each other. So once we find one, we have then essentially found both. So because I'm bisecting that big angle, I'm splitting it into two. So I'm going to take 75 degrees and I'm going to divide it by 2. And that's going to give me then the measure of the smaller angles. And they happen to be the two angles that we are looking for. So cut that in half. We have 37.5. We're talking angles, so we have degrees. So all I had to do in that problem was divide, and then I had my answers. So that's us identifying midpoints of segments, as well as identifying bisectors and trisectors of segments and